All right, this is Josh from DMC. I'm going to let you go ahead and introduce yourself and what you do and what's awesome about your presentation.
Okay, yeah, great. It sounds like the microphone's on. Perfect. So, hi everyone. As I was introduced, I'm Joshua Jenkins with DMC, and today I'm going to be talking about the LabVIEW Solution Builder and how this can take PPLs from a dream to reality. I know we all heard earlier about how we should avoid PPLs at all costs, and I'm not here to completely dispute this because there are notable issues, but I'm going to talk about how LabVIEW Solution Builder is a tool that helps mitigate some of the issues with working with them and make it a better overall experience. First off, a little bit about me. I'm a systems engineer at DMC, the BS in mechanical engineering, and I'm a certified LabVIEW and test stand developer. And one extra special credential I learned yesterday during the industry survey, I have the distinction of officially being the youngest attendee of the conference this year. So that's a really cool thing for me and reinforces how fortunate I am to be up here speaking to everyone. So that I'll talk a little bit about DMC briefly. We are an engineering consulting company spread across 13 offices across the country in various geographical locations. So we have a footprint nationwide with over 200 employees at this point and still growing, with 5 main divisions that we work in. Our manufacturing automation is our largest division that works primarily with Siemens, Rockwell, PLCs, SCADA systems, and they automate large lines. We have digital workplace solutions, app development, embedded development. But our best division, in my opinion, is the one that I work on, which is the test and measurement automation. This is the team that works primarily with the LabVIEW and NI platform in general. And we're a relatively large team. We have about 30 to 40 engineers total that work across the entire NI software and hardware platform with various certifications. It's a really great team that I get to work with and share a lot of ideas and collaborate with. And that's part of what led me to being here today, was sharing some of those ideas and getting inspired to come up here and talk about this tool that I've been working with and piloting at our company. With that out of the way, agenda's up on the screen. We're going to talk about a little bit of why you might want to use PPLs and how they're typically used, like the quote unquote old way, and what that typically leads to. What does it mean? Where does it leave us? And then we'll talk about the LabVIEW Solution Builder with some level of detail, and then get into some tips and tricks that I've learned while working with it that help make it easier to use and will hopefully make you more successful if you decide to pick up this tool. And so let's start with the motivation for using PPLs. And first off is, what are PPLs? I'm not getting into that too much. It sounded like from the raise of hands earlier, most people in the audience have a general idea of what PPLs are, but here are 2 presentations given at past conferences. The first one was by Zebra Technologies talking about how to effectively use PPLs. I believe they were working with about 170 PPLs in their projects. They have a lot of detail on how they went about doing that and maintaining it. And then at the 2021 GLA Summit, the author of this tool, Phil Joffrian, actually gave a presentation with another collaborator where they talked about this. I'm just here to rehash a little bit of it and continue to spread the word about this tool and what it does. So why use PPLs? Well, there are a few reasons why you might be motivated to do it. They enable componentized architectures. It's one of the options that you can use for source distribution, but this has the advantage of being compiled code, which is slightly more performant. It prevents IP from being publicly available if you don't want that to be available to the end user. It also runs better with test stand if you're using that. You can point directly to the same test code that you're calling in test stand and LabVIEW at the same time. We'll wait for that to come back real quick. It's a lot easier to debug builds that are smaller and componentized. So if you're programming into libraries with the intent on eventually putting them into PPLs, that gives you a much smaller scope for an issue can be if you can isolate which library is the problem. Additionally, validation can be easier because of this scoping, and revalidation is also easier. I know a lot of industries, if you change any code, that entire set of code that was changed needs to be revalidated. So having to retest one PPL as opposed to an entire executable can save time, and a lot of customers might be happier with that. Additionally, it's not always guaranteed, but you can be encouraged to have better dependency stability, because if you're thinking about the dependencies you're pulling into these libraries and how you're building them, trying to avoid circular dependencies, you might think about that a lot more along the way instead of looking back after you have this reuse code built up over 2 or 3 years and realizing the dependencies are a mess. And then also it encourages better development workflows. We heard yesterday about how we should all be unit testing, and we should. Unit testing for a library once you've completed building it and built it into a PPL is a lot easier, and it is a very good checkpoint within your development workflow that can be encouraged among other things. So, brief overview of that. Let's talk about how this has typically been implemented in the past. And one of the fundamental challenges is namespacing and compiling. Here I have an example of 2 libraries where library B has some function in it that is called by a program in library A. When we compile library B into a PPL, we get the new namespacing library B.lblibp in your function, and that's what we want library A to call. But unfortunately, oftentimes we end up with something else. Library B gets pulled into the PPL that A is making, and now we have a brand new namespace. And this can break a lot of call chains. This can create some really interesting debugging scenarios, and it's not always the easiest to work around. And one way that has been approached in the past is you have your source libraries dependent on the compiled library in your project. Unfortunately, this provides a bit of a development bottleneck if you ever find any issues in this code, because if library B has some issues, you need to close your original project and go back to another project so you can track down that change, maybe make a debuggable PPL to track it down, and then rebuild and port that back over to the original project to work with. And that can take a lot of time. That's not always the easiest process to work through, and setting up these projects can be time consuming, a little tedious, and especially when you start getting into some complex dependency relations. This isn't necessarily the best scenario for dependencies, but this is a fairly realistic scenario where the arrows denote direct dependencies and the order that you might have to compile all of these generic libraries. There have been some notable improvements over time. The MGI Solution Explorer makes this process a lot easier. Once you get the project set up, you can then go and compile these sequentially if you have the right setup. That does really help. And another big one that will be important later is the replace with function, where you can pick a library and say, replace this with some other library, a packed library, and save all those calls. So if you're originally developing in source code and decide to switch over to wanting to work with PPLs, you can make that swap all at once, save everything that gets changed, and that is really helpful. So that's a lot of a process to try and get this all set up, and there's a lot of overhead. Once you've figured out the libraries you're working with, you have to determine that build order to figure out how to put the libraries next to the compiled libraries they're dependent on, and cascade down. And if there are any circular dependencies, you have to go into the code and find those yourself. That can be a pretty time-consuming process, especially as you get into larger projects and larger architectures. And anytime you develop a new library that needs to go somewhere into this build process, you have to repeat that. And that's a lot of time that goes into this process of just trying to maintain these PPLs on top of all the issues that we heard about earlier, where they can lead to some pretty ludicrous issues. And you have all these project files and build specs to maintain across all the project files, and the build automation become really complicated and fragile as a result. And so what does this mean? Well, that's why I say PPLs are a dream. They're really hard to use in a broad manner. They create really nonsensical errors, and they're one of the biggest issues to work with a lot of times. There's a lot of overhead involved in trying to make this work right, and if you get it wrong somewhere along the process, it's not always obvious where that mistake is. And so many of us choose not to use PPLs at all, whether because of all these issues or because our favorite presenter at GDevCON told us you really shouldn't be using these if you can avoid them. And to borrow a term from him, our Homeland Security advisory with working with PPLs in this state is somewhere from high to severe. You're probably going to run into a lot of issues. And this is something that was recognized by NI at some point. LabVIEW NXG was going to try and rework PPLs into GLLs, is my understanding. That was going to try and address some of the pain points and make these easier to work with, but as we all know, that's not happening. So that leads us to figure out, if we want to use PPLs, how do we do this? And that's where we have the LabVIEW Solution Builder. LabVIEW Solution Builder was written by NI's Phil Joffrin. It's a side project that he has worked on and that I collaborated with him on. On the screen is a QR code to get to his GitHub repository for this. There are a few open issues, and I have a pull request out with a few fixes that I've tried to implement to make this work better over time as I've been working with it. But this is a publicly available tool where all the source code is available, and I do believe it resolves many of the troubles and issues with working with PPLs and makes the workflow a lot better as a developer. I'll give it a few seconds if anyone else is still trying to grab that QR code. So let's briefly talk about what the solution builder does. So every time the builder runs, it's going to parse every build spec that you've pointed at. There's a path input that specifies where we should be looking for the build specs, and the solution builder will inspect every single build spec within that path and put them in a build order, with the highest level libraries being called first, built, and then you'll move through the build order, swapping out the source code for compiled code at every step along the way. So what this means as a developer is you're no longer putting a compiled PPL next to a source library for your dependencies. You're working entirely in source code. And this alleviates some of the issues for debugging, makes it easier to work with, and you don't always have to deal with fighting whether or not you're supposed to be working in source or compiled or having different source controls to maintain that. As these swaps are happening, it's maintaining the proper namespacing by making sure that we're not sucking in libraries that have already been built into new PPLs like we saw earlier. And the best part is all these changes are made in memory. And I think that's an important thing to repeat, that all changes are made in memory, which means when you run this builder, you'll get PPLs that are dependent entirely on PPLs, and all your source code stays dependent entirely on source code. So there's no cross-linking, cross-referencing, or having to deal with saving or maintaining those changes. And that really does make it a lot easier to work with as a developer. I'm going to briefly hop over to a demo here for the sake of the recording. I pre-recorded a video of me doing this. I'm going to live narrate it, but this is a quick one to just show how easy this can be to set up. So what I've decided to use for the demo is the observer registry that's part of the JDP Science messaging library available on VIPM. And so we'll get this video started. Yep, that's running. So I already created the project. I added this initial library that I want to build into the project. And the first thing I'm going to do is go and check the dependencies and see what libraries the observer registry is dependent on. And when I expand this window, we'll see that there are an additional 5 libraries in VI-lib that we're dependent on. So I'm just going to grab all of those and pull them into the project itself so I can create build specs for all 6 of these libraries. So once I see all the libraries are in, I'll go and add a build spec for a pack project library. Takes a second to load sometimes. And now I'll go through and set up the build spec. I'll add the observer registry as the top level here, and then change the build specification name to something meaningful. I make it match the target file name, and then I pick a destination directory. Here I have an exports folder. C:/PPLs is another great valid location as long as you're consistent, and then come into the additional exclusions and make sure to exclude dependent packed libraries. That is a big, important setting that we need that I'll go into later. And then here in the project, we see I already have the other 5 set up for the sake of time. Those were all set up in the exact same manner. And so I save the project, and now I'll switch over to the LabVIEW Solution Builder. Here we have the front panel. I put together some settings because in this case, I want my version 1.0 release. I want to make sure it's all rebuilt. And I point the path to our project, and I'm going to click run. And this initial bit here is when the build specs are being inspected. We see them now populated to this table, and we have a build order that is completely different from the order that was in the project. We see a few flashing screens. There's an issue with the way LabVIEW loads items into memory with projects. There is a very crude fix I have implemented where it opens all the files from the libraries into memory. And then we see as we're going along, we've already built the first 2 libraries. We're building the 3rd library now. And the 4th one, we'll see a quick message once it switches to that saying that we're swapping the libraries. And so this is when we're swapping the source code for the compiled code and making all those changes in memory before building. And with that, in the span of just under 3 minutes of work here in this demo, I've put together build specs and created a project that can build 6 libraries out of VILib that are distributed through VIPM into packed project libraries that are dependent on each other. This is something that wouldn't necessarily be easy to do if you were trying to do the previous method of putting the packed libraries as the dependencies for the source library, since then you'd be making changes to code in VILib, which we all know is something that we want to avoid whenever possible for making sure that we're consistent across systems. And getting started can really be as simple as that. To go into the manual equivalent of what this is doing under the hood, and if you needed to try to do this on your own without the tool, this is where that replace with function comes back in. So it'd be the same as going in, seeing your library dependencies, selecting replace with, pointing to your PPL that you've already built, and then saying cancel when it prompts you to save, because we want this change to stay in memory. And when we do this, we now have a new project file where we can see that there are changes open because we have the dirty dot at the top of the project, but now that source library is gone. So what the solution builder is doing is it's going through for every build spec in every library and doing this process for you. And so that's a really powerful adaptation on how we previously worked with this. And there are actually a lot of ways to be able to invoke this. We saw the direct usage of the LabVIEW code just now, but there are also command line and CLI usages. And if you're anything like we are at DMC, you'll probably want to offload a bit of this building to a CI process, which is also available. And I'll get into a little bit of details later, but there are these numerous ways that we'll talk about to invoke the solution builder and call it. So it gives a lot of flexibility with how you're using it. And then as I mentioned, the additional exclusions need to make sure to exclude dependent packed libraries. That's always a good box to check no matter what. But in this case, it makes sure that you only have one copy of each PPL that comes out and prevents build errors.
All right,
Perfect.
we can continue Josh's explosive presentation.
Yes, so.
Brought the house down. It was awesome.
Thanks everyone for sitting through that impromptu intermission. So, yeah, are we all good on the AV side? Perfect. So right where we left off was talking about the various ways to invoke the solution builder. We saw the LabVIEW invocation, the command line and CLI. We'll get into details on those, have a few extra parameters that can work with, but first we're going to talk about the common input parameters between all 3 of these methods. Yep, so the preview option, this will allow you to have the solution builder parse through all your build specs and output to the table what order it's going to try and build everything in. Additionally, there's a build cache that's generated on each build that will tell you if you even need to rebuild a particular library. If no files have changed, it's not going to rebuild, and the preview will indicate that for you. It'll tell you what's already built and doesn't need to be rebuilt, what will be built, and what order it will happen in. This is really useful for setting up your build specs the first time and seeing where you're at in the process and double checking dependencies are being parsed properly. With the ability to have the build cache, there's also the solution to force a rebuild. So in the presentation, in the demonstration, I said, if you want to do a version 1 release and you want to make sure that everything is rebuilt regardless of its state, you can tell the builder to just rebuild everything, ignore the build cache, and move on. There is a version input. This is similar to the MGI Solution Explorer, where it applies the indicated version to all build specs being built, with the additional feature where if it is left at 0000, the build specs version information will be used instead. So the version information already contained within each individual build spec we pulled out and used if you leave it the version at this default value. There is a log file path that will create a log of all the different build specs that were built, what their original states were, and give some traceability there that you can work with. And then the last parameter, which is the only one that is fully required, is the path input. As I mentioned earlier, this is what tells the builder what build specs to look at, and there are a few different ways to use this and to identify your build specs. The first one is if you point at just a directory. In this case, I'm in my C project example directory. If you give a path to a folder like this, every build spec or every project within that folder recursively tunneled down. So if you have any subfolders with project files, they will all be checked, and the builder will attempt to order every single build spec between all those projects. Alternatively, you can point it directly at a specific project, as we did earlier. And the last method, which gives the most control and has the most features within the path, are the solution files. These are a type of markdown that is coded in, and there are a few different tags that we'll talk through. There's an example at the top right that's probably a little hard to see, so I've blown up the sections as we talk through them. We start and end with the solution tag to indicate the start and end of the file, and then we give a project path. This is the same kind of project path as we have in the LabVIEW implementation, but it can be a relative path, an absolute path. It can be forward or backslashes, and you can have as many project paths per solution file as you want. So you can have one solution file that specifies 5 different project paths to inspect and work with that, so you can really customize the implementation of that. In this case, I have the example of project's example library C, the LV-proj. And one of the big distinguishing factors of the solution file is you also have the ability to add a packed lib. This is a functionality to add a packed library that has already been built outside of the knowledge of the solution file, and you are telling the solution builder that this file exists, I want you to use it. And the main requirement is that you have to give a path. Obviously, it needs to know where to find it. Again, this is another relative or absolute path. And then there are also optional name and target items where target defaults to my computer. You can specify it as my computer, or if you have an RT target, you can specify that you want to go to an RT target. And you're just indicating what this packed library, what target this library was built for. Additionally, if the name of your source library is different from the compiled library, you can indicate that difference here. Again, by default, it assumes that the packed and source libraries have the same name. So you don't always have to include that. And with these different flags, the double colons separate. So path, you give it the path, a double colon, you can give it the name. That's how you distinguish between the different arguments. And then not included in this example is you can also indicate the version that you want. Briefly looking at command line and LabVIEW CLI, has all those same functionalities that we've talked about with the UI controls and the add packed library. You can also specify the general target, and there is a quiet argument that will tell the solution builder to close its front panel when it is completed. If you want it to just run and close, you can include quiet. And if you indicate keep split projects, that's skipping a cleanup step that I honestly don't know too much about. That's part of what Phil's included, but I just want to include this as one of the options that is there. Documentation on all of these usages is also available in the README on the GitHub repo. So if you want to go diving deeper into these implementations, there's good examples and documentation on how all these different arguments are used in the various implementations. And so with that, let's look at what's left to maintain. If we do this in the quote unquote old way that I talked about earlier, you would probably need these 5 different project files to make the observer registry that are keeping the dependencies between each of those sub-libraries together. And then you might have an MGI solution file that looks at all 5 of these different projects. You might have debuggable build specs and non-debuggable, and that's a lot to keep track of and to maintain for just this small sample size of one library that we're trying to build. And so instead, what we had in the example I showed earlier is we have all 6 libraries put into one project, and then we can put that in one step of the MGI Solution Explorer where we're invoking the solution builder. In this case, I've written a custom plugin for the MGI Solution Explorer. You could also call directly to the command line since that is a native implementation within the MGI Solution Explorer. I'll talk in 2 slides about what that plugin looks like that I've written. But this is a lot less to maintain, obviously in this small scope, but with all that, you do still have to have the caveat of dependency management is still important. There is no getting away from that. The solution builder may help identify when a circular dependency exists, but it's still on you as the developer and maintainer to try to avoid those when possible and make sure that your dependencies are clear and neatly defined. And so just a brief look at how we're using this at DMC right now on our first pilot project that we're working with it. We have a builds directory that has project files dedicated to the build project where we specify these PPL build specs and the NI packages that will install them to their final location when we want to run, and we build them all through the MGI Solution Explorer. We have a neat solution there that has one step that helps with our CI process, and then 4 build steps that are all calling the Solution Explorer, and then one last step that does our test and deployment utility. And with this, we're currently building about 100 total PPLs using GitLab CI using test. Oh, not sure what that's about, but we're using the Git actions that we heard about during the 7x7. So we have a YAML file set up. GitLab on every push will run our CI pipeline unless we have an optional tag to tell it to skip. And this helps us identify whenever we make any breaking changes. We're able to rebuild our whole project and all the involved PPLs. And that really keeps us on top of knowing when we make these changes, and it helps as all CI processes do. Looking just briefly at a breakdown of what our solution file is building. That first step has 27 PPLs and an installer for putting them all on disk. We have 53 of our iFactory pattern PPLs for all of our devices that we want to be able to use with the executable. We have 17 CAN libraries that are being put together. Then we have our application and the installer, and then an installer for a test and deployment utility. So we're able to bundle, as I said, about 100 PPLs and 20 to 25 installers all into these 6 neat steps because of the solution builder. And this is what our plugin looks like. So I simplified the UI a little bit. I kept a lot of what was already configurable, and the big change that I implemented here is I added a skip build cache step. Since we're running this and rebuilding every time in our pipeline, for our pipeline, we have it set up to not bother creating the build spec or the build cache because that saves a lot of time overall. That was just a quick feature that I implemented to help save time. And this also launches the front panel of the solution builder when it runs. So if you're running this locally, you can follow along with the progress and know if you can go get coffee or a snack before it finishes building. And this is also distributed via an NI package. So this is a really easily accessible plugin that I was able to write up pretty quickly and neatly confines the solution builder into something that's very usable. And that's the main potatoes of what I have. I have a few tips and tricks and the tough lessons I learned while working with this initially as I've been helping sort out some bugs and issues, but hopefully these will maybe, if anyone wants to pick up this tool, get you started a little bit quicker and resolve some of the issues. The first one is I highly recommend including a build log for all your build specs. That crude implementation I alluded to earlier with having to load up all the library files. If for whatever reason something isn't opened all the way, then you might see instead of if you told it to swap out a specific library for a packed library, you might still see the source version here. And this has saved a lot of time in debugging, being able to just check these build logs and figure out, did I actually swap out the source code, or am I in some weird intermediate state that will cause a lot of problems in running down the line? This goes back to, again, that crude implementation and why I needed to implement it. If you don't have all of your VIs in memory, instead of getting the image on the left that we want that's asking us to save or cancel, we'll see that we have the options to save or don't save. And this is because LabVIEW doesn't load every VI in a project in when you open the project. Saves resources, makes it open faster. But the downside of this is if you're trying to make programmatic changes in memory and something's not in memory, it's going to leave memory as soon as you're done with it. So the way I worked around this, again, very crude, is to put all of your libraries, classes, and malleable VIs. If you are using malleable VIs, which I will echo Darren from earlier, if you can avoid malleable VIs, please do. It will save you a lot of headaches. But here I have the set of libraries I'm building, and then I have a build dependencies folder that has a few extra libraries that I'm not worrying about building, and some malleable VIs that get called as well. This enabled us to get building. I'm currently trying to work on figuring out a more elegant approach and solution, so you don't have to do this and have these extra build folders. With this, there is a caveat that there is a reasonable limitation on this. If you've ever seen this pop up, dabort in image c.pp crash, this is something that I've run into a lot, and it is related to opening too many graphical objects on your operating system. There is a limit set in the Windows registry. I can't speak to Linux or Mac on this, but there is a very neat knowledge base article for LabVIEW, another QR code here that goes into details about this type of crash and how to resolve it. There's links to Microsoft forums on how to update that registry value and give it a little bit higher of a limit, but that's something you probably don't want to mess around with too much, and try to constrain your project file size more so than editing your registry, but sometimes it's hard to avoid, so that is out there. A few short little tips after that. I'm relatively new to CI working with this. Someone in the crowd who knows more than me might be able to help me with this, but I was finding issues with the build cache or the compiled object cache on the runner that we were working with, where I could build locally, but the runner wasn't building anything. It was failing early. I found that just programmatically opening and closing each project solved that problem for me. It gave me a consistent starting point for the build process. It feels fragile. I am definitely open to talking over dinner with anyone who maybe has been more experienced with Git CI processes and how to avoid this, but that is an area for improvement. But this did help out immensely and save a lot of time and troubleshooting and made our pipelines more successful. A few last things. This is kind of just a quick punch list of some of the smaller items. I found that building more libraries speeds up the process. So if you're having a library you don't think needs to be built, but it's used in 2 or 3 other libraries, building that is going to improve your build speed overall because you're only compiling it once instead of those 2 or 3 times. With the usage of the malleable VIs, we heard earlier about how those can be really finicky and nonsensical at times. I found that adding a pre-build action for any of the libraries that call any malleable VIs that checks for bad VI states and recompiles has saved the day and led to more consistent builds instead of me getting errors that then I go and troubleshoot and find that this should be perfectly fine. And I just need to give the compiler a little nudge here. These last 2 are a little bit interlinked. CTLs I've found sometimes have unapplied changes. If you go in and inspect the build right before it compiles, I'm still actively working on this, but I think this is a source of some of the issues that are still out there that I'm hoping to have a pull request out for in the next few weeks. And then if you have a class that's not included in a library, keeping that namespace properly gets very difficult just because it doesn't have a PPL to be built into, and you might have multiple different libraries that pull it into its compilation process. So fortunately, a lot of public utilities have a few classes like this. If you can avoid it in your own development, that will ease your time. And then following solid principles in general is always a great practice, but that really does help with maintaining your dependencies and keeping the scopes of the library smaller so that the debugging is an easier process. And with that, I have one more thing that I think is more of a bug. I think I talked to Darren earlier and confirmed that this might be a bug that I'll be taking to NI, but I found that if you have a class private data or anything that gets unbundled that has a fully namespace class, like if you drag the class off of your project file and onto the diagram and you see the .lvlib and .lvclass, for whatever reason, when you're doing that replace with function, it doesn't swap on the unbundled node. There's some edge case in the logic that prevents that, so I recommend just giving the name of the class or anything that doesn't have that namespacing to make your time a little bit easier to work with that. Again, that's something I'm thinking I'm going to elevate as a bug and talk to NI about, but that's just something to be aware of that's out there. And with that, I think I got through this a little bit quickly, but I think this would be good to open up to any questions that might be out there.
Did I catch that you're able to chain builds across several projects? So if I've got 5 projects with 5 PPL build specs in them, I can pull that into these tools and build those and not have to have everything in one project.
That is correct. The reason we've opted not to do that for the time being on our project is because of, again, my really crude implementation for loading everything into memory. If you're loading up all the VIs, closing them down, opening a new project, opening it out, that's a lot of overhead in terms of just opening projects and all that VIs behind it. So that can save time to put it on one big one, but it's very workable to have them in separate projects.
Hi, not so much a question, but a comment. You mentioned several times how developers need to identify their circular dependencies in a project. I don't know your particular process for doing this, but I enjoy viewing a project's VI hierarchy, and it'll show the relationships between the different libraries, and circular dependencies show up as a dotted squiggly line. So just visually, that's a nice way to see where those might exist.
Okay. Wow. I don't know if that's something I was personally familiar with, but sounds like a great method to help work with that. And if you don't notice that before you try to run the builder again, it will output an error saying a circular dependency exists, and then you can go and look at that hierarchy and identify that a lot quicker. Are there any other questions? I'm not seeing any other questions out there. Well, thank you everyone for having me.